Okay, welcome to 7.3.1. This one is talking about sample means. So here is this is my population distribution. This is all 50 kids. So this is my population distribution. Okay, so I gotta make a guess at the mean of all 50 students. Okay, it's like maybe right here. So I'm gonna say 168. And the standard deviation, well, I would say more than half of my data is contained up 10 and down 10. So I'm going to say my standard deviation, and this is my population mean. So I used the wrong symbol. Population mean, it's still not a great mu. Okay. My population mean, I'm going to say is 168, and my standard deviation, I'm going to guess at 10. Now let me go calculate it. Okay, so it turns out I'm amazing. My actual population mean was 168.96, and my actual standard deviation was 9.6. Okay, now you can select a random sample of 5 students and calculate the mean height. Do that 4 times. So you get 4 samples of 5 students. Go. Okay, good job. Now I'm going to sketch out what the mean sampling distribution might have looked the sampling distribution of the means might have looked like. 3, 4. Okay, there. I did my best to sketch out what our dot plot might have looked like. So the shape of our dot plot, it is roughly symmetric, and we have a peak here at 169. So I'm going to say roughly symmetric, peak at 169. Our center is there at that peak at approximately 169. 169. Let me try that again. Is roughly 169. This means that it's approximately normal. Our variability, though, is much less than what we saw up here. This was stretched out between 140 and 188. Here we're between, I don't know, 164 and 179. So our standard deviation is, let's say, half, 3 up or down. So I'm going to estimate our standard deviation to be about 3. So you can see it got much less. We see here that our mean, okay, what's wrong with my handwriting? Oh, my board is tilted. Okay. Our mean of our population is approximately equal to the mean of the means. This is the mean of the sample means. The double mean. Okay. The standard deviation of our sample means, though, is the standard deviation divided by the square root of n. Because we had, here we go. All right, now we're over here. So, lastly, we've got to compare our two dot plots. Well, they are both, the shape is similar, is symmetric, peak at 169, approximately normal. The center is the same, but the variability of the samples is much smaller. Is, okay, not ISS, is much smaller. And that corresponds to what we saw up here. We also see from our shape that if our population is approximately normal, our sampling distribution is approximately normal. Okay, so now we've got some important ideas that we have to add on to here. So let's scroll on over here for our important ideas. Okay, so the first one, the mean of our sampling distributions is equal to the mean of our population. This is our population mean. This is our sampling distribution. This is the mean of the means. Distribution mean. And we saw that our standard deviation of our means is equal to the standard deviation of the whole population divided by the square root of the number of samples. So this was our population standard distribution, standard deviation. And this is our number of samples. Okay, then regarding what is normal, we saw that if the population is approximately normal, our sampling distribution is approximately normal. And this is a throwback to last time, but our sampling distribution, we can use z-scores. So if it is normal with some mean and standard deviation, then we can find the z-score by taking the statistic minus the parameter. So the statistic being the mean that we're looking for, greater than 30 or less than 10, minus the parameter, that's the actual population mean, divided by our standard deviation up here, standard deviation of our sampling distribution. And that is 7.3.1.